Hi, my name is Julia Schmale. I'm based at EPFL, and I'm going to introduce you to our project Arctic Climate Change, exploring the natural aerosol baseline for improved model predictions, in short, ArcticNAP. However, we won't be napping during this project. With a collaboration with the Universities of Stockholm, the University of Helsinki, Leeds, and of course the Data Science Center, we would like to tackle an important problem. The background is that the Arctic is experiencing accelerated warming, and this induces environmental change, which in turn changes emissions of short-lived climate forcers to the atmosphere. So this is a climate feedback loop, and this feedback loop is very poorly described in numerical models. The graphs show you a couple of examples of important environmental changes that we think have an impact on the atmospheric composition that is climate relevant. There is less sea ice, there is more phytoplankton blooms, and there are more fires in tundra and the boreal forest. So are these processes driving climate relevant atmospheric composition changes? To answer this question, we use a data-driven model. It will be a latent variable approach. We will use a unique combination of input data that is long-term data from ground-based observatories around the Arctic. So this is in situ data covering 3 to 4 decades. We will also use remote sensing data based on satellite observations of phytoplankton, sea ice extent, fire, and we will combine that with data from numerical weather models, such as air mass circulation, precipitation, and so on. Then we will try to discover relationships between all these environmental variables and our target variables, the aerosols and trace gases, and then describe these relationships statistically. Then we will run Earth system models, or have run them already, and see if the same relationships surface in the Earth system models. If they do, then we can improve them. If they don't, then we can identify critical missing processes. So the impact that we hope to have is to make available a new data-driven modeling approach for environmental long-term change analysis. We will improve our process understanding of the climate feedback loops, and we will facilitate better numerical model simulations for the future Arctic. I'm happy to talk more about it, and thank you for your attention.